14, page 152, 153, doing question 3. This is Samir making a rectangular run for his pet rabbit. That's very nice of him, isn't it? So, pet rabbit, rabbit run. It has 5 meters of fencing. He wants to make an area of 1.5 square meters. Essentially, I've got this. The area is going to be 1.5 meter squares. I've got x for the length, y for the width. In other words, being a rectangle, I've got 2 x's and 2 y's, and the perimeter would come to 5 meters, it says so, and the area I've taken care of. I've got to write down 2 simultaneous equations in x and y, the length and the width of the run. In other words, length, width in that order, and what the dimensions. In other words, work out x and y. So I know that 2 x's plus 2 y's make 5, and that's the perimeter sorted out. And I know that x times y makes 1.5 meters squared. So these are my simultaneous equations. I've got one of these and one of these. You've not seen one of these before. Right, so if I go for the bottom one, I've got x equals 1.5 over y. If I substitute this into the x portion of the linear equation up there, I should be able to get an equation with just y's in it, and then we'll take it from there. Alright, so if I work down here then, I've got 2 lots of 1.5 over y plus 2y comes to 5, tidying up a little bit. I've got 3 over y plus 2y is 5. In order to get this horrible y on top, if I multiply everything by y throughout, you should solve it, shouldn't it? So I've got 3 plus 2y squared equals 5y, and rearranging that, I'll go 2y squared minus 5y plus the 3 equals 0. So here it is. If I write it up here, I've got 2y squared minus 5y plus 3 is 0, and I've got to sort of merge it with, well, try and factorise it. I'd have to merge it. I've done the merging, so let's just go for it. So 2y and y, the only way to make 3 is 1 times 3 or 3 times 1. My inclination is to go that way. Double minus 2y squared minus 2y minus 3y makes minus 5y. Minus times minus is a plus. I'm happy. So y is going to be 3 over 2 and y is going to be 1. In other words, that's 1.5 meters. So I've got 2 possible answers for the y so far. Now, as is usual, we work out the corresponding x values by substituting into something quite simple, really. What if I use this equation here? I've got x multiplied by 1.5 equals 1.5, using this part here. So that's where I'm coming from. So x is going to be 1.5 divided by 1.5. X is 1 meter. Here, substituting in the y, I've got x multiplied by 1 equals 1.5. So here, x equals 1.5. So what have I got? I've got y equals 1.5 when x is 1, or y is 1 when x is 1.5. Essentially, if I'm working out the dimensions, if x is the length, for example, let's go for the biggest one and write down x equals 1.5 here, and here I go for the smaller y value, the corresponding y value, and that's it. That's Samir sorted with his rabbit hutch problems. Now here, we've not done one of these before. I didn't do a video on it, although there is one further back in the chapter for sure. Now, it's really crafty. A pair of simultaneous equations are 3, 8 and minus 2, 13. Right, okay. The first equation is y equals 2x squared minus 3x minus 1. The second equation is linear. Find the second equation. Yeah, look at that. If these are the solutions, then that is an x value, that is a y value, that is a different x value, and that is the different y value. See, 4 sets of answers, or rather 2 sets of answers, 4 individual values for the x and the y's all combined. So we're given the first equation being quadratic. We're not asked to solve anything. We have the solutions. Now, if the other equation is linear, we can treat it as a y equals mx plus c arrangement, since linear equations follow that pattern, and we can merely use these 2 sets of values for the x and the y as coordinates. If I use them as coordinates, I can work out gradients and intercept, and in so doing find the equation of the the remaining linear equation that matched this equation here to get these answers. So look, do you remember gradient? Gradient is going to be difference in the y divided by the difference in the x. Okay, when we did diagrams, you know, on a grid, difference in y over difference in x was the gradient. But we can do it by calculation as well. Difference in y, so I'm going to go 13 take away 8 divided by minus 2 take away 3, and that's going to give us 5 over minus 5. Therefore the gradient is minus 1. So the m part is the gradient, isn't it? Alright, so far I've got y equals minus 1 x plus c. In other words, if it's minus 1, it's just minus x plus c. Now to find the intercept, I merely take any of these coordinates and substitute in the equation, and the easiest one to use, of course, is that one, because they're all positive values. So what have I got? I've got y is 8, so 8 equals minus 3, because x is 3, plus c. Therefore c is going to be 11. So what's my final equation? Here's my answer. I've got y equals minus x plus 11, or to tidy up, y equals 11 minus x, and that is my linear equation, which when merged with this quadratic up here will give me the solutions 3, 8 and minus 2, 13, and that's all there is to it. Really easy. Now I really like this question. I've not seen one like this before. It's simultaneous equation with magic squares. So magic square, each side has the same total, so that's all comes to 24, and they tell us that anyway right there. I think I'll work in blue. Now here's another kind of magic triangle, magic square, magic triangle in which the sum of the three expressions on each of the three sides is the same. In other words, that little bit is the same as that little bit, which happens to be the same as that little bit. Now I'm going to use all three. In order to make some simultaneous equations to complete the magic triangle, I've got to work out all these little bits here. In other words, if I work out what x and y is, I can work out 2x plus 2y, etc., etc. So let's just begin to merge these things. So dealing with this side first, I've got 11 plus 2y plus x plus 1, that's that one, is equals this side, 11 plus 2x plus 2y plus y. I've got to tidy this up, haven't I, really? What have we got? Well, let's lose the 11s straight away, subtracting 11 from each side, and I've got, I can get rid of 2 y's as well, look at that. So the 2 y's can go with those 2 y's, and I'm left with, not in yellow, can't see it, I'm left with x plus 1 equals 2x plus y. If I lose the x to the other side, I've got x plus y equals 1. I just subtracted the x to the other side, it's gone. So that's one part of the simultaneous equation. Let's put that in green, and I need to get another little green one. I've used these two. I could use this one with this one, or this one with this one. I'll do this one and this one, so let's work now. I better work down here, hope it fits. So I've got 11 plus 2y plus x plus 1 equals this side as well, x plus 1 plus 2x plus y. Hopefully this will work nicely. Well, what can I get rid of? Let's get rid of that x with that x. Let's get rid of that one with that one. Let's just fix these up a little bit. I've got therefore left over 11 plus 2y equals 2x plus a y. Let's bring my 2y over there. I've got 11 equals 2x, y minus 2y is minus y, and that will be my second equation. Okie dokie then. Now let's just merge these two little green things and work down here and see what we can do. So let's go back to blue. I have got x plus y equals 1. I have got 2x minus y equals 11, just reading it around the other way. And let's go ahead. Now this is dead easy, because if I go and add these things, y plus minus y has gone, and I've got 3x is 12, and the whole thing's falling apart beautifully. So x is going to be 4. If x is going to be 4, I can merely sub that back into there. So I've got 4 plus y equals 1, and therefore y has got to be minus 3. So these are the two values I'm going to be working with. Y is minus 3 and x is 4. So let's just fill up these bits and pieces. That's 2y. 2 times minus 3 is going to be minus 6. Alright, this is x plus 1, that's 4 plus 1, that's 5. This side, I'm just working around anti-clockwise, 2 x's, it's going to be 2 4's, which is 8. A single y on its own, that's going to be minus 3. 2 x's plus 2 y's, well that's going to be 2 lots of 4 plus 2 lots of minus 3. I thought I'd write it down in case I make a mistake. That's going to be 8 minus 6, which is 2. So this little part is 2. Let's just test it out. This is the bit that makes me nervous. Now apparently this should round up to the same. 11 take away 6 plus 5. Okay, so 11 plus 5 is 16. Take away 6 is 10. So I've got 10 on this side. 11 plus 2 is 13. Take away 3 is 10. Ooh, that's 2 out of 2 so far. And finally, 5 plus 8 is 13. Take away 3 is 10. Yep, I've got a triangle of 10, so I'm really happy. I've filled up all the bits and pieces, and I really like that question. So that's the end of the CES 13, and that's the end of Unit 2. I have worked very hard doing this. I really need you, well you need you, to look at all these videos and study them and absolutely cane the examination that's coming up.